Hello class, I'm here to talk about problem 7. Actually, this is 7. The other one was 5, not 4. Sorry about that. And I'm gonna rename this too. I'm just using the same template to save time. So problem 7 on your book reads right here, refer to the gasoline sales time series data in table 15.1. So all I did, I went to table 15.1, which is right here, and then I just added this values over here. Okay, so this are these values. Okay, and then the problem is asking you to compute a 4 week and a 5 week moving average for the time series, then compute the MSC for the 4 and the 5, and then which one appears to be the best. However, they are also asking you to recall that the MSC for 3 weeks is 10.22. So we're going to see which one is better. So let's go back here. Well, if it's a 4 week, that means we don't have anything before for 4 weeks. We start on week 5. Remember, I can go ahead and hide this. I just use all the same here so I don't have several tables below. It's just easier to see it. But let's just start with week 4. So if you have 4 weeks, so we're gonna average the values for the last 4 weeks. Right here, 20. So now all you have to do is drag down here, and Excel is gonna do the work for you. Okay. All we did, he updated from B4. So 4, 5, 6, 7, and then B5, so 5, 6, 7, 8, and right here B6, 6, 7, 8, 9, and then B7, 7, 8, 9, 10, so always 4. So the error is always going to be my forecast minus my value. And here is, these are my values, okay? So now we're going to do the square error, or the error square. So he's going to do equals to this value, caret, we call it caret, and then 2 for square. And then we're going to drag this value, this formula. Okay, so now remember, square error or error square, the MSC stands for mean square error. So the average of my square error values. So we're going to average these values right here, enter, and that would be a 9.65. Okay, so now we can go ahead and this doesn't have to be bold really, but it doesn't matter. So let me split this right here. I'm gonna do for the 4, it's 9.65. Let me move it here actually. No, let me do like this. 4 weeks, I'm gonna do equals to this value right here. Wait, it helps if I don't type anything else that I shouldn't. And then for the 5 weeks, we're gonna calculate now. So I'm gonna put it back, the columns that I was there hiding. Here you go, 5 weeks. So the only difference now, instead of starting right here on week 5, we're gonna start on week 6 because we don't have anything before for 5 weeks. So we're gonna do the average, and then we're gonna be using the same values. Okay, the values don't change for week 1, 2, 3, 4, and 5. So now we're just gonna drag down here. There we go. And now we're gonna do the forecast right here minus my value. Okay, we're gonna drag it down. It really doesn't matter because when you do the square error, the negative sign is gonna go away because minus times minus, that's plus. It turns into a plus sign anyway. So we're gonna square this error. So we can calculate the mean square error, therefore the average of these values, which is 7.41. So for 5 weeks, you have A equals to 7.41. I like doing equal. I don't like typing values because if you do modify anything on your table, you don't have the trouble to locate which ones you have to change. You will change everywhere. Okay. So now you have, so compute 4 week and 5 week moving average. Oh, we did. So actually, the table is letter A. So we can move this down here. I'm just gonna put done. Then there's your MSC, and I was asking which one appears to be the best number of weeks of best data. Well, we are including for 3 weeks, which is 10.22. We're looking for the smaller mean square error value. So 10 seems to be the highest. And then we have 9.6 for 4 weeks, and we have 7.41. So definitely uh, for the amount of data that we have, um, the best MSC is for 5 week, um, oops, 5 week moving average, which is the smaller. And then you would be done with problem 7. Oh, didn't mean to do that. You will be done with problem 7. Just trying to format it a little bit. And here, oh, here we go.